works. So non-concurrent coplanar force systems. Here are the steps, and you can press pause if you want and have a read over the steps that we're going to do. And this works no matter how many forces we have acting. So we're given a reference point that it doesn't have to be in the center. We've got two forces here. And the first thing we're going to do is resolve the forces into the horizontal and vertical components using cos for horizontal and sine for vertical. And then by looking at where the forces are pointing and where they're placed, we can tell whether they're going to give a clockwise moment or an anti-clockwise moment. So now we've done the resolving of forces, we can try and work out what the moments are. It's very important to note that the moment caused by a force is the force times the perpendicular distance, and it's in Newton meters. So horizontal force components need to be multiplied by vertical distances, and vertical force components need to be multiplied by horizontal distances, otherwise no moments occur. So we take each of these components of F1 and F2 and multiply them by the distance at which they act. And this diagram shows you the force components and the distance away from the reference point that they act upon. So we've got a table that will fill in. It doesn't matter how many forces we've got. It's always the same method. So we've worked out the x and y components using cos and sine. Then we multiply each force by the distance, and we can tell whether it will give us a clockwise or anti-clockwise moment by observation. And we always say that clockwise moments are positive and anti-clockwise moments are negative in Newton meters. This is F2's horizontal component, which causes an anti-clockwise moment. That's why it says minus 900 Newton meters in the table, because it's anti-clockwise. And F2's vertical force component, it's negative. That just means it's downwards. And we can see that it would cause an anti-clockwise moment. Then we just add all of the positive and negative moments together, and we're left with an overall anti-clockwise moment. And then all we need to do is add all of the horizontal components together, add all of the vertical components together, being careful with the signs. Then we use Pythagoras to find the resultant force in newtons. Then we use trig to find the angle at which the force acts. There's our resultant force, 1,892.79 newtons at an angle of about minus 55 degrees. And if moments equals force times distance, then we know the distance that this force acts from the center here is the sum of the moments divided by the sum of the forces. And that comes out to be 0.42 meters. But we know we have an overall anti-clockwise moment. So that tells us where we need to put this force on the diagram. There's two possibilities at this angle. So 1,892.79 newtons at a distance of 0.42 meters at an angle of about minus 55 degrees. It has to live here, because if we placed it where this red line was, it would cause an overall clockwise moment. And our sum of clockwise moments is minus, so that means it's anti-clockwise. Always the same method, so good luck working out your questions.